Okay, so let's continue to LO 1.1c. We need to verify, you need to know how to verify the homogeneity of equations using dimensional analysis. What is dimensional analysis? It's a method used to check the mathematical relations for the consistency of their dimension based on the principle of homogeneity. So basically physicists use this method, use this analysis to check whether their equation is consistent, okay, before they introduce the equation, before they do experiment based on the equation that they build up. Okay, so what is the principle of homogeneity? Okay, principle of homogeneity state that all terms appearing on both sides of an equation must have the same dimension, or in another word, very simple way of understanding this mathematically, you should find that the left hand side of the equation should be equals to the right hand side of the equation. So let's say for an example, what does this mean is, let's say I'm a physicist and I'm going to introduce this equation. So before this, I need to check whether it is consistent or not. So I need to check the dimension of S must be equals, okay, to the dimension of the whole thing here, which is the dimension of U T plus half A T square. So it's easy to determine the dimension S here, which is S is displacement. S used here is displacement, which displacement is measured in unit meter, which is length. It is a length of a something, okay, of a path, length of a path. So as we know that the dimension for displacement should be, the dimension for displacement is length. So we need to make sure that all of these terms on the right hand side also have the dimension L. Then we can conclude that the left hand side of the equation is equal to the right hand side of the equation. The dimension of the left hand side should be equal to the dimension on the right hand side. So this term here, okay, you need to know how to solve this term here, how to do the dimension analysis on the right side of the equation. So first we need to know why the uses of dimensional analysis is, first one is to determine whether a physical equation is correct or not, okay, dimensionally. And then the second one is to determine the unit of the physical quantity, which we have done on the previous learning outcome. And the last one, the uses of dimensional analysis are to derive or construct a physical equation, which all physicists does. Okay, so the first rules that you need to remember is dimension cannot be added or subtracted. What does this mean? Meaning that if we have L minus L, okay, we just have to ignore this and we have to take the answer as just as it is. Okay, so L, the answer would be just L. So later we will do more on how to solve this, okay, involving the addition and subtraction. Okay, the validity of equation cannot be determined by dimensional analysis but obtained from theory or be determined by an experiment. Okay, so whether the equation is valid or not is not determined by dimensional analysis. Okay, it is determined by an experiment. So all physicists have to do experiment. There's no such thing that you don't like experiment that you can be a physicist. Okay, for F, the dimensionless constant is always 1. Okay, so let's say you want to find the dimension of any numbers. So let's say 1.3. Okay, the dimension is always equals to 1. So any numbers, if you put a square bracket around it, the dimension of it is always equals to 1. This rules is also for the refractive index. Okay, and then for the angle, so whether it's 90 degree or it's 25 degree or 360 degree, the dimension is always equals to 1. And the ratio of two quantities having the same dimension such as the strain, the dimension of strain equals to extension over original length, which is both of this is a length, so dimension of this is L over L. So when we solve this, it will be equals to 1.